In this video, we're going to solve a couple of examples based on the Thevenin theorem. Here, we're going to have a dependent source. Whenever we have dependent source in a circuit, while finding Orthovinion, we need to do some extra steps. We're going to talk about it. Now, how do you know it's a dependent source? A dependent source always is going to be a rhombus. Okay, so if you see rhombus, that's definitely a dependent source. Now, if you see inside an arrow, that is a current source. If you see plus and minus, that is a voltage source. Now, if it is depending upon the current, say this I0, that's a current. So it's a current dependent current source. If you see a voltage, V0 or V1 or Vx, so it is a voltage dependent current source. Same thing here. If you see some constant times V0, it is a voltage dependent voltage source. Or if you see some constant times Ix, it's a current dependent voltage source. That's how we know it's a dependent source or not. Now, the first few steps are similar. Step 1, so here he's asking about find the Thevenin equivalent circuit across 6 ohms. So even he's not asking about finding the current or voltage or power in the 6 ohm resistor. He's asking about the equivalent circuit across the 6 ohm resistor. So remove the 6 ohm resistor and label the terminals. So that's what I did here. Everything else is same. Now our goal is finding VAB. So that's a step 2. Okay, so B, I'm going to ground it. So all I need to do is find VAB, which is Thevenin, which is VA minus VB. So in this case, VB is 0. So all I need to do is find VA. Now, to do that, I'm going to use the nodal analysis. From the nodal analysis, I'll find VA and VX, or I'll find VY. Once I find VY, VA minus VY equal to 20 volt. Okay. VA is the positive, so VA minus VY equal 20 volts. So VA equal 20 plus VY. Now, even though there is a voltage source, there won't be any current passing through it. Remember that, because nothing is connected. For current flow, there should be always a closed circuit, then only current will flow. It's just like you're connecting your extension cord from the power outlet, but you're not connecting anything to the power outlet. I mean, you're not connecting anything to the extension cord. So there is voltage available at this node, but at the same time, there won't be any current because there is no load connected. Now, I'm going to apply KCL at Vx. So I'm going to take every current is going out, IA, IB, IC. Always I usually take current going out. So IA equal to Vx minus 30 over 10. IB equal to Vx over 5. IC equal to Vx minus Vy over 5. I always take the current going out, so that way I can see Vx minus something, Vx minus something, Vx minus something. Now, at Vy, apply KCL. If I apply KCL, I have IP plus, I said IP, IQ and IR. All three currents are going out. Okay. So IP equal to Vy minus Vx over 5. IQ equal to minus 2I1 and IR equal to 0, because as I mentioned, since it's open circuited, there won't be any current passing through it. Now I1 equal to Vx over 5. I1 equal to Vx over 5. Now I'm going to substitute this equation 3 in equation 2. We'll end up with Vy minus Vx over 5 minus 2 instead of I1, Vx over 5. I'm going to multiply this with 5. We'll end up with Vy minus Vx minus 2Vx equal to 0. Vy minus 3Vx equal to 0. That's my equation 4. Now I'm going to solve equation, let me say, I'm going to take this as equation 1. It's already in there. It's equation 1. Equation 4, I'm going to solve them together. So what I did here, equation 1, I'm multiplying with 3. Equation 4, I'm multiplying with 5. So that way the Vx component get cancelled out, end up with Vy equal to minus 90. So our goal is finding VAB, which is Thevenin, which equal to 20 plus Vy. So 20 minus 90 will give me minus 70 volts. So my Thevenin equal to minus 70 volt. Okay, that's my step 2. Step 3, we'll find Orthovinion. While finding Orthovinion, replace all independent voltage sources with short circuit. That's we already know. And replace all independent current sources with open circuit, because that's the internal resistance of a voltage source is 0. So that's a short circuit. Internal resistance of a current source is infinite. That's open circuit. Now, third one is, if there is a dependent source, keep the dependent source as it is. Okay, this is the different method. So when there was an independent sources, we replace them and find the Orthovinion. But if there is a dependent source, we're going to keep it as it is, because that dependent source is going to affect the circuit, or it's going to influence the circuit with its resistance. So we want to find out how much resistance that dependent source is supplying. So that's the reason we need to include that. Now, while finding resistance, we will have only dependent source. If you have dependent source only, it's not going to supply any current because there is no independent source. So what I'm going to do, I'm going to connect a 1 ampere independent source here between the AB terminals. It need not to be 1 ampere, it can be 10 ampere, it can be 100 ampere, or it can be 1 volt or 100 volt. I usually go with 1 ampere, it's easy. So RAB equal to VAB over 1 ampere. VAB is VA minus VB over 1 ampere, which is VA over 1 ampere. So RAB equal to VA over 1 ampere. So I'm going to repeat it again. So to find out how much internal resistance this dependent source has, I'm going to connect a 1 ampere source and calculate VAB. So VAB is the voltage between these two terminals. Once I have VAB, RAB resistance is nothing but I can put VAB over 1 ampere. As I mentioned, you can put 100 amperes, 1000 amperes, or you can put 1 volt too. If you put the voltage, then RAB equal to if you put the voltage there, it's just whatever the voltage divided by the current. So all you need to do is find the current there. So you can, if you find the current, then you can find the RAB if you use the voltage source. I always prefer to use a 1 ampere source. It's easy for calculations. So RAB equal to VAB over 1 ampere. VAB is nothing but VA minus VB over 1 ampere. VA over 1 ampere. So all I need to do is find VA. Okay. Some students always get confused. Oh, I already found VA right there. Can I use this VA or Thevenin? No, we cannot use this because that circuit is different. That circuit has a voltage source right there and another voltage source there. Okay. Now, while finding RAB, we have different circuit. These two voltage sources are gone. At the same time, I have another current source. So this is entirely different circuit than the previous one. So I need to again find the VAB. So here at I'm going to say Vx and at VA. So at Vx apply KCL. So I'm taking I1 down there, I2, I3, I1 plus I2 plus I3 equal to 0. I1 is nothing but Vx over 5, Vx minus 0 over 5. I2 is also Vx minus 0 over 10. I3 is Vx minus Va over 5 equal to 0. So the total voltage is 5Vx minus 2Va equal to 0. This is my first equation. Now at Va apply KCL. Ia plus Ib plus Ic equal to 0. Ia equal to Va minus Vx over 5. IB minus 2I1, IC equal to minus 1. Now, one student asked me in today's class, he's saying that, can I take the current flow towards down instead of flowing towards A? No, you shouldn't take current flowing down, because my goal is finding resistance between AB terminals. So I want to find the VAB, voltage between AB terminals, not BA terminals. So since voltage, I'm saying VAB, so voltage at point A is higher than voltage at point B. Since voltage at point A is higher than B, so I'm taking current. I have to take the current going up instead of going down. So this is the KCL at VA. And I'm going to substitute I1 equal to Vx over 5. I1 equal to Vx is right there, Vx divided by 5. Once I substitute that, we'll end up with VA minus Vx minus 2Vx equal to 5. Now I'm going to solve those two equations, equation 1 and 2. I end up with Vx equal to negative 10 and VA equal to negative 25. So my RAB equal to VA over 1 negative 25. So basically what is happening here, usually we do not have negative resistance. So in this case, I end up with a negative value, negative resistor. That indicates that whatever that element is, it is supplying energy all the time as long as there is external source or whatever the dependent source is. So that is the reason I have a negative resistance. So step 4, I'm going to build it back. Thevenin, Orthovinion. Thevenin equal to minus 70 volts. Orthovinion is minus 25 ohms. I'm going to, since it's not exactly a resistor, I put a box in there, and 6 ohm resistor. I equal to V over R. So basically minus 70 over minus 19, that is 3.68 amperes. So that's the current flowing through the circuit. That's with the dependent source. I'm going to stop this video here. Next video, I'm going to solve another dependent source problem. Thank you.